this video we're going to get into actually transforming the exponential functions. We're on page 1 still of the course pack. Just like in previous units, we're going to use the variables a, h, and k to talk about transforming or transformations, A is still going to control your vertical shifts, vertical stretches. Or compressions. Okay. If A is less than 0, then you will have reflections. If the absolute value of A is greater than or equal to 1, if it's greater than 1, you will have vertical stretches. I'm just going to say it becomes or looks more like a right angle or L-shaped. And if the absolute value of A is less than 1, it's a vertical compression. And it's going to be more archy. All right, so it's not going to be as sharp. H values are going to control my horizontal shifts. And remember, this is kind of the opposite of what we think when we look at it in an equation. If H is greater than 0, so horizontal shift right. If H less than 0, horizontal shift left. And then last but not least, we will have K values. These are going to control our vertical shifts. And if K greater than 0, it's going to say vertical shift up. K less than 0, vertical shift down. So going on to page 2, I'll do a couple examples. Just like with, and I'm going to be going from red to blue. Just like with previous functions, we want to kind of find a starting point. I would suggest you use kind of like in the middle of the curve for each of these. You can eyeball it, right? I mean, it doesn't have to be exactly perfect. You'll be able to get close enough. Again, the first thing I'm going to do is do my shifts, horizontal and vertical. So I see I need to move to the right. Then I need to go down. After that, I'm going to do reflections. So backwards L to backwards L, it's the same shape, so no reflection. Now I want to look at which one is more steeper to archy or not as sharp. So the red is steeper, which means the blue is more archy. So archy, if I end on archy, it's a compression. Okay, so now I'm actually going to go back and talk about the rate of change. If we think about rate of change as how fast or slow something increases or decreases, if something increases or decreases fast, then it's going to be a stretch. If it increases or decreases really slow, it's going to be a compression. All right. Fast is going to look steeper. Slow will be a compression. And in number 8, I'll go from blue to green. Again, starting out with my shifts to reflections to stretches. Again, just get close. Blue to green, I'm going down and left. So down to left. Reflections is going to be based off of my shapes. So blue still looks like a backwards L. Green looks like a backwards L. They're both the same shape, so no reflection. So now again, I want to think about it now in increasing or decreasing, fast or slow over a given interval of time. So if I pick out from where I put this mark, and I say I'm going to go over 3 units, that means I'm going to also go over 3 for both of them. Actually, I'm going to use 1 for this particular example. And I'll explain why in a second. So if I go over 1, I'm going to run up until I intersect the graph. So over 1, up 1 has a slope, change in y, over, change in x. Now if I go over 1 here, then I go up 1 all the way until it hits the graph, which is right there. So I want to roughly find this distance, which is 1, 2, 3, 4, 5, 6 and a half. If I want to find the slope of this line that would run through these 2 points, right? 6.5 over 1. And from there, I think about it as which one is bigger, or which one is right faster. Bigger is going to be more. So 6.5 is greater than the slope of 1. 6.5 was my green, is bigger than the slope of my blue. The slope between those 2 points is greater. So means it's increasing faster. Blue is slower. So I'm going slow to fast. If I end on fast, it's a stretch. So that's kind of another way to think about it. Again, I'll do one more example and kind of tie up this video. Again, number 9. I'm going to start with my stretch or shifts, reflections, end on stretches, just because I still think they're the hardest. Again, I'm going to pick out 2 of the points. And this time I'm going to go blue to green as well. So blue, I need to go up and then left. So up, left. Because I'm starting with blue, it looks like a 7. Then it becomes an L. They're different shapes. So there is a reflection. Now again, I'm going to go 1 over, and it doesn't matter left or right. I would go in the direction of the way that you can then get to the graph. So I went over 1, and then I went up 1, 2, 3 until where it hit. If I go over 1 from here and then down 1, this would be changing y as 1, or -1 since I went down. Over 1, positive, since I went to the right. This one, changing y, was +3 over changing x, which was to the left 1. So this is -3. This is -1. And again, we're concerned with the absolute value right here. So which one has the greater slope if I don't worry about the sign? Green slope is greater than blue. So green is fast, blue is slow. I started slow with blue, finished with green, finished with fast. So I have a stretch.